Kevin Brown. He's the CTO of Schneider Electric's IT division, and he's going to kick us off with a discussion of the buzzwords of edge computing and what lies underneath them.
That's right. Thank you very much, Fred. Thank you, everybody. So, as Fred mentioned, I'm the CTO for the IT division, and for those this morning who saw Dave, who was my boss, I thought he was excellent, by the way. You have to say that, I think, whenever your boss presents, but he was on the panel. We do take the lead for all things data centers within Schneider. So I have groups that's looking at the overall industry trend, and we reach across from medium voltage, low voltage, all the way down to what's happening at racks and coolings. So I wanted to talk a little bit today about, I titled this From Buzzwords to Reality, because we talk about edge computing, there's no shortage of buzzwords in this industry about what it is and what happens, but wanted to share with you some of the things, at least our view on a number of things, particularly around managing the edge data centers, and some of the things that we're learning and seeing and where we're investing, and certainly, hopefully, that'll be an interesting part of the discussion. There we go. So I think if everybody's seen this, there's no shortage on hype about the edge. Edge computing could be the next multi-billion-dollar tech market. Again, the masters of understatement as our industry is. Microsoft CTO, edge computing can make industries massively more efficient. And I always like those terms, massively more. I don't know what massively more actually means, but it sounds impressive, right? So we're in this mode where we're kind of convinced that edge computing is going to be great, and it's funny I find it ironic how confused we really are as an industry about what it is. Nobody can actually define it. I think even Dean Nelson was up here this morning saying this. So, 4 key characteristics, a working definition, demystifying, and as an industry, even today, we still don't really know what it is or how to talk about it. So it's a really fascinating thing that on one hand we're saying it's the next multi-billion-dollar business, and on the next hand we're saying, well, what is it? Right? I think we all know conceptually where it's going, but usually when these things start, it's understandable, it's confusing, but the concept's not new, right? So we've been working at this for a while, actually, as an industry. You could argue it goes back. This is a document that we found. I know you can't read it, but there's interesting things in the back. Think about content distribution networks. We started talking about those in the 90s, actually, right, with Akamai. And then really the benchmark we put in, say, 2012, Cisco introduced the concept of fog computing, which is still being used out there. Let's say that's the benchmark of when we really started talking about edge computing. That was 6 or 7 years ago, and we're still sitting at conferences here today trying to figure out what it is, right? So obviously it's pretty complex. We don't really understand exactly what it's going to look like or what the opportunity is, but we know it's big. And the clicker is not really working. Okay. And in fact, the views on hybrid architectures are really quite interesting. Here's at least 4. You get lots of these types of drawings that come out, and my favorite one is here, where it says, well, it's very simple. We've got edgy data centers, we got edgier, and then we have the edgiest, right? So that's very helpful, I think. That tells us a lot, right, about what it is. And you get all these complex diagrams, and I've had lots of debates. I see some of the people in the room that I've had debates with about what does it really look like, and we have this very simplified view. We try to keep things simple so that we can understand them, and we've been out touting this for a couple of years. Generally, at a very broad level, our philosophy is there's going to be 3 types of data centers in the future. There's going to be these big centralized cloud data centers. You're going to have, call it a regional edge data center. Maybe those are 1 to 5 megawatts that are servicing local areas. But really today, and what we're talking about is this action around we call the local edge. And you get down, this could be anything from 1 rack, like at a retail store, up to maybe 100 kilowatts of IT. And we see different variations on it. And I would argue that most of the debate that we're having in the industry today about what is the edge is really trying to define what is that local edge. And again, there could be 5 layers, there could be 3 layers. You see all these different variations on it. But really, for us, as Schneider, as an infrastructure supplier, they all they have a similar feel to them, right? And you run into the same type of problem is I'm going to have thousands of these things out there, and what do I do about it? How do I deliver them? How do I manage it? These are the pragmatic reality of the problem we're trying to solve. And it's all based off, and I presented this last year at this event, so if you've seen this, I apologize, but in order to make this hold together, I wanted to talk a little bit about what is the resiliency at the edge, which is really a theory we put forward, and we're seeing this play out particularly in retail. All right, so you think about this local edge. The argument here is basically, using the tier standards, and my friends from Uptime always get mad at me when I present this because we put availability numbers, but then we went and I sourced it, so it wasn't us, so somebody else, put these percentages against the tiers. But if you take a look and say, just as examples, suppose these percentages are right, that if I have a Tier 3 data center, I'm at 99.98% availability, and a Tier 1 is at 99.67%. I believe these are very dangerous ways to view availability in terms of percentages because it's not meaningful in a human brain. That does not sound like a big difference, 99.67 versus 99.98. However, when you do it the other way and you say, okay, how many hours of downtime does that actually calculate out to? You see much more meaningful numbers where actually the difference between Tier 3 is 1.5 hours versus 29. So it's a big difference. And I would argue that most of our local edge data centers are probably like a Tier 1-ish. And we've actually gotten pretty good at the bigger data centers at building them as Tier 3. And I would also argue, and I think you kind of started feeling that with some of the presentations this morning, particularly from Dean Nelson, right? He's talking about, if I have my Uber app and say I have a downtime of a few minutes, how much data they're losing is, I would call it the old paradigm of failure really was around the data center itself. If I'm inside my data center and I have a power outage to that rack, I count that as a failure. But nowhere in that conversation have we historically had about, is the application being served to the customer? So if that data center, if say my whole data center goes down, using Dean's analogy this morning, I forget what he called them, but it was within a region, right? So if I have a zone go down, it completely fails over to another app. The app keeps running, is that really a failure? Right? So this is kind of the new paradigm that we're dealing with, is how do I define a failure? If I'm able to maintain the customer experience on my app, we didn't really have a failure, the whole system was still working, right? But if the user has an interruption of their experience with the app, then that is a real failure. And the challenge that you've got is when you start connecting these together, and again, just use this math. This is just a math exercise using these percentages. If I take a centralized data center that runs at this downtime of 1.6 hours per year, and I connect it into a local edge data center that, for example, is running a Tier 1, the availability of the person who's dependent on that local edge data center, it goes down. It gets worse. It's worse than Tier 1 when you do that. The math comes out, now I've gone from 29 hours of downtime on a local edge data center to the customer at the other end is experiencing 31 hours. So you have to multiply these together. So the availability of having a highly available centralized data center connected to a very poor local data center has a very negative impact if that's the first point of contact that the customer is connecting to, right? Make sense? And this is the problem at this local edge is it's usually it's not unusual to see them connected to something like this. I would argue a lot of our local edge data centers are even worse than Tier 1, right? Completely unmanaged. There's a lot of chaos that happens. No monitoring staff. There's no local staff really that's taking care of them. It's not like you go to some of these, you see some of the guys marketing the industry. You go to a big Tier 3 data center. There's one that I went through. I had an armed guard following me around as we were touring the data center. But yet, if I go into a retailer, the janitor has access into the closet. Think about the cybersecurity concern just with that. And this is becoming real. This is playing out in real time. And so the argument is edge sites, we have to start thinking about these being treated as mission-critical data centers. So the challenge for the industry is how do I go do that? Because it sounds easy, but it's actually much more difficult than we would have anticipated. And we've been working on this now at least for a couple of years. So that's the resiliency of the edge theory that we've put forward. We have a white paper on it. And that's playing out. We're seeing it actually happening. And particularly, again, I'll talk about retail quite a bit because that's the kind of the experimental dish where this seems to be happening because we see so many retailers who are trying to figure out how to compete against Amazon. And one of the ways they're doing it is by improving the store experience, which means more IT. So when more IT is going in, it's becoming more critical for them to make sure that those applications are available. I talked with one retailer where they said, hey, if a customer walks in, we've now put tablets into all of our associates' hands so that if a customer goes to buy something, they can just order it right from the tablet, right? And by the way, and if anybody ever asked us if we have something in stock, the answer is yes, we have it in stock. It may not just be in this store, right? So you can go do your virtual mirror, see what I look like. You find something you like, the associate will be there to take the order before the customer leaves the store. So their survival, they're viewing their survival as being dependent on making sure that local edge is available. And historically, retailers were not what I would consider best practice at deploying in these stores, and it's really changing. So the question is, if that's the case, There's some things we've been working on is, these are three key areas that we need to work on to make the edge more resilient. So first of all, the ecosystem has to work together differently than we've ever had to do in the past, right? This sounds quite simple, but I can tell you, trying to work with other vendors, and I'll give you some examples, on how do I actually deliver out to 3,000 stores located in various areas, different versions of a micro data center that has all the IT included and all of the management tools somebody needs. Right? It's actually quite complicated to get all of the different people working together. Second thing we'll talk about is the management tools, and we've made a pretty strategic, what we think is a strategic shift in our approach on management tools, and I'll get into that. And then the third is, practically speaking, what does it mean to implement AI, and how do I do that? So if we're going to solve this problem of creating very resilient local edge data centers, these three things are going to be, you have to have these three in order to make it work, is our view. And we're starting to bring things into the market to show that. So let's talk about the ecosystem for a second. Fundamentally, if you take this local edge phenomena that's happening, there's basically two big challenges. One, I got a whole bunch of them out there, right? Again, thousands of stores that I might have to. Think about retail. And retail's not the only one, but think about retail. And the other fundamental problem is you have nobody on staff at that site, right? It's not like I've got, an electrician. You might some of people who are colo providers, what have you, they have staffs of people at these data centers that can go and fix things and work on them and look at alarms and do all this stuff. You've got nobody out there. So if now all of a sudden I need to take this local edge data center and manage it just as well as I do this centralized data center, you don't have the staff to do it, and you got a whole bunch of them. So this is what this is forcing is the physical infrastructure vendors, guys like us, the IT equipment manufacturers, the system integrators, managed service providers. This is a simplified model. Maybe there's more people, but in a lot of these retail sites, for instance, it's a local reseller, right, that's now called a managed service provider who is actually servicing that environment. So we have to work with them differently. I mean, these guys, it didn't exist 10 years ago. All of a sudden now they're ones. So, and it's also forcing the customer to think differently. So the customers now, they need to define much more carefully what it is that they're trying to do. What is the application they're trying to provide? And then how do they communicate that so they can get the IT equipment they need that matches what they need on the physical infrastructure, and then I got to have someone integrate it, deliver it, and by the way, I got to do it in 3,000 stores globally. So that has forced us to work together in a much different way than what we've had to do in the past. And in fact, some of the challenges customers are seeing is, hey, I had this local edge data center, I installed it, it was supposed to have X amount of power, X amount of stuff, and somebody showed up and there was an extra server in there, right? And it was because some third party that had come in that they were experimenting, they were doing a pilot with some new technology at the store. They showed up and they said, oh, there's space in the rack, I'll just throw it in there. All right? So all of a sudden they've lost control over what's happening at that site. So how do I integrate this stuff? How do I get control over it? And it's really, we've been working a lot with, for instance, HPE's one example. I'll show you some others. And I feel pretty good that we're making progress on this front, right? But for us to work with HPE so that they can deliver a full micro data center with the IT integrated meeting a specific customer application, right? Because it starts with they go and they talk to the customer, what's your application? That's driving the rest of the requirements that are there. But we had to completely rethink how we work together in terms of our supply chain. We had to rethink a lot about all these different pieces of equipment that we have, right? Rack PDUs, and all of a sudden people want security. It's like all of the things that we can make, they want to jam into one box, and it's a challenge when you're trying to figure out how do I get all of that to fit with the IT and get it delivered to a customer site and give the customer a seamless experience. There's a lot that has to happen on the supply chain side just to make that happen. We haven't had to do that before. Historically, you just allowed things to meet at the customer site. That's not acceptable, because then if it's meeting at the customer site, when it gets assembled, you don't actually know what was assembled. So we want these things being delivered fully configured, right? So these are examples of, we've done a lot of work with HPE that's out there. We're also doing work with guys like Scale Computing. We got some things happening with Cisco. We just recently announced, for instance, now we've worked with Cisco to certify so that all of our racks can actually ship with Cisco UCS environment installed, okay? And they'll still maintain the warranty, simple things like that. And other examples with Store Magic and Dell EMC. So there's lots of examples like this coming out, and each one of them is interesting because as we work with these different partners, how are they actually, their preferred way of working, how their supply chain is set up, changes the way we work with them. Okay, so this is a kind of a human change element. So that's one thing. So I think we're actually making progress with the ecosystem, and we're making progress on how do we actually work together to deliver these systems. But if you talk about management tools, and again, I already talked about this. I've got so many edge sites, no on-site IT, facility staff. These are, some of the voice of customer that we get is, hey, I get so many alerts. I don't even know what to do with them. I don't even know which ones are important. So it's, it's one thing when you're in a big data center and you got someone who's highly trained running a network operation, and we've all seen these, right? Where you walk in and there's, 10 screens up on the wall, and there's very educated people looking at them, sifting through the data and understanding what's going on. You take that same thing now and point it at 3,000 micro data centers, right? I mean, it's a nightmare. How do you actually, and you get nobody who knows what they're doing. So how do I do that? Who's accessing my equipment? And then it's even interesting, we run into this problem of, can I get the IP address or not? Right? This is a practical problem that a lot of people have is, hey, you're going to stick a bunch of stuff in the rack, and I need to manage more of it, and I understand it, but I can't get the IP addresses. I can't get it from my IT department, so you got to manage that for me and help solve that problem. So anywhere from like very complicated problems to very basic. And the big one at the top is, hey, stop telling me about what the status is. Tell me if I have a problem before it's too late, right? So this is, again, predictive analytics that everybody's excited about. So if each edge site has to be managed as a complete micro data center, right? Kind of our own old way of doing this as an industry is, I've got a bunch of devices, UPSs in our case, and cameras and rack PDUs, but even at the IT level, you have similar things happening. You don't want to really view it that way. What you really want to do is view it as one thing, right? So I've got this site, this micro data center. Is everything okay? So I'm driving here very much on an example about, kind of from our point of view, we've got to consolidate all that and make it into a single IP address. But then also we have to work together and integrate this more openly with what the IT management tools are as well, so that I can truly get a dashboard of what's happening with that micro data center. Okay, and so this, so our side of this is coming, right? So early part of next year, we're going to start shipping these things with consolidated IP address, one view of what's happening. But then the key with this is how do I not lose granularity on the data? Because underneath that is an awful lot of important data, right? That can help me identify that. So in order to do this, we're convinced, we are in the midst of re-architecting our software suite, all right? That's going after this local edge data centers and making it cloud-based. And it's a completely new cloud architecture. And here's all the standard reasons why. It's easy to get started, pay as you grow, maintenance-free, update cybersecurities, automatic software updates. But the big one that we're really also focused on is a couple of things, is access from anywhere and anytime. And when you think about that ecosystem, when I go into a cloud-based architecture for management, now it's not just the person on-premise who can see the on-premise data. I can have experts at Schneider, I can have our managed service provider, I can have the IT vendors. Everybody in that ecosystem can be looking at the exact same data at the exact same time. This is the power that comes with it. Because now you no longer are having these conversations. We have conversations, why is this UPS alarming? Well, what's it saying? Well, what do you mean what it's saying? It's right on the screen, and then they have to start reading what they're seeing on the screen. Those days go away. If I go into a cloud architecture, now every customer can see the exact same thing. The guy troubleshooting the problem, the managed service provider who might have to actually go and fix it, everybody's working from the same data set, right? So that's one of the things that I think is a huge benefit. And it's also the only way that you can get to doing analytics in really ultimately machine learning or artificial intelligence is how do I get a big enough data set so that I can start doing something meaningful? And we thought this was a fairly straightforward problem until we started doing it and realized it was much harder. I always love getting these news clips. So here we go. There's 4 to 12 steps. By the way, also very clear and straightforward. So this says to do AI. So one guy says there's 4 training steps you need to do. This one says 5 baking steps, 6 implementing steps, 7 successful steps, 8 easy ones, 9 baby steps, 10 steps. If you're not Google, apparently you need 11 rules, not steps, 11 rules. And then there's 12 excellent steps for the last one. So it's all completely clear, right, on what you need to do AI, right? I mean, you get done with this, and you're like, what do we actually do? So, of course, we're no better than anybody else. I don't pretend that. So we said, no, there's not all these steps. What we determined is that there's 4 key ingredients. It's completely different, right? So, so this is again, our philosophy that we're putting in place ourselves internally is, first of all, we needed a secure, scalable, robust cloud architecture. The amount of data that I need to take in is large. And by the way, one of the conundrums that you have, one of the contradictions that you have is, I only want to see the data that's most important. The problem is, I don't know what's most important today. So we have to collect everything, because in the future, we don't know what the parameters that might be important for us to be able to run machine learning algorithms against them. So it's really, there's kind of a catch-22. Until I collect the data, I don't know what's important, so I have to collect all of it. It's tricky. So that points you towards the second one is, I need a data lake, and you need massive amounts, but not just any data. You still need to normalize this data. So you can't just take any data and just pump it into a data lake and have it be meaningful. You got to normalize it in some way. And I've seen analysis out there saying, I can't remember off the top of my head, but it's like 80 or 90% of the time data scientists do is actually spent normalizing the data. And I'm getting some nods from some people who are agreeing with that. You also need a talent pool of subject matter experts with deep knowledge of the system behavior. I mean, we have guys on our staff who can take a look at an environment of a UPS is in, and they can predict pretty well what's going to happen because they're experts in this area. I know people who can walk around a data center, and by the way it sounds, they'll know there's a problem with a belt in one of the HVAC systems. These guys exist. The question is, how do I take that knowledge and start augmenting it? So artificial intelligence, I mean, that's artificial. We're talking about augmenting these subject matter experts because we don't have very many of them, but I need to be able to take what's in their brain and utilize it at scale. And then ultimately, you need access to machine learning algorithm expertise. Okay, so this is what we've been putting in place over the last 2 years, and I still think we're very early in this journey, but we've got a good set of data that's out there. So again, aggregate data securely, create specific AI use cases, identify your critical variables, normalize the data sets, provide compute power to analyze the data. That's kind of the solid foundation that you put in place before you can do anything. And we'll talk about normalizing data in a second. And then you got to get a really good data scientist who can collaborate with those subject matter experts. And then I go and develop the algorithm, train it, and then how do I test and refine those things over time? So we are building a dedicated team of data scientists, but they can't just work on their own. What we're working on is, how do I connect them in with our subject matter experts? How do I connect it in with the data set that we're building? And then we can actually start implementing something interesting. Okay? And we've been working on this for 2 years, and it's only been in the last couple of months that we felt we had enough data to be able to do some meaningful analytics. It took us much longer than we expected. Okay? So let's talk about the challenges of normalizing data. So take something relatively simple, right? UPS power. We've been doing UPSs for years. It's easy, right? It's not a big deal. Well, we started digging into it. We have 9 different ways that we report power on our UPSs because nobody ever thought it was a big deal in the past. So you have things like, where's the measurement taken? Am I looking at input power or output power? Is the UPS reporting watts, VA? What metric? Because if I have 2 UPSs reporting 2 different things and I put it into a data lake, I can't run analytics against it unless I normalize those 2 together. How often is data reported? So within Schneider, we do power quality analysis where you're down at the wave. So we're down to microseconds reporting, and then you have kind of typical UPSs within a couple of seconds, maybe, right, that we report. But if you take a look at a building management system, it might be even slower. So now I got a data set coming in, and I'm trying to figure out what I can run against, and if everything's at a different timestamp, I have to be able to understand what it is. Is it even at the same time? So is everything synchronized at the exact same time? Sometimes this is not the case. And then also the context of the data is important. So, we have examples. This is the classic example. I need to have a context of a data center. So if I have a data center and it's 2N and there's a power outage on one side, the UPS goes to battery and the generator turns on, generally everything operated the way that you want, but there was still a failure, so you want to report that there was a power failure. Well, that kind of context is important. If you're just looking at a raw data set and you don't know that context, then sometimes you can make some mistakes. So anyway, and is it utility grade? How accurate is the data that you're reporting? So if I got data getting reported from 2 different devices reporting the same thing, but one's more accurate than the other, how do I know which one's right? So these are all things that sounds simple to go and do this stuff, but when you start digging in and really trying to understand it and take data scientists and have them apply at it, this is what they have to start doing. This is the first step, and it's a lot of work to get done. And ultimately, what's the problem we're trying to solve? And I'll give you, so these are use cases that we're actually bringing to market. All right, so this is stuff, this isn't theoretical. This is things we're actually bringing. I love this. I couldn't resist because Homer is always funny. But you got all this information coming in, and he's sitting there staring at his tablet and looking at what's going on. In the meantime, he's got the nuclear reactors melting down behind him, right? So he's lost in the data and losing sight of the big picture. This is the problem that we're trying to solve. Too many notifications, alarms. What are even the thresholds that you should set? And again, in the context of a big data center, you have people that work on this and refine it. You have staff that work. So we provide tools. The staff kind of refines how you're handling these thresholds. You go out to 3,000 micro data centers where nobody really understands what's going on, and it becomes a very almost unmanageable problem. So here's an example of what we're doing. So this is, again, we're in the early days, but this is, we are investing heavily in this area. On the left-hand side is a real screenshot of what are the events and the logs that you would see typically out of what we call our EcoStruxure IT platform, okay? So you can see it runs through, and it's giving you a lot of data about what's going on. And by the way, all of that data is important. Like I took our guys and I said, okay, guys, tell me, do we really need to be reporting all of this? And they could sit there and explain to you line by line why all of that was necessary for us to store and understand. So we're taking all this data, we give it to a human, and a human's supposed to sort through it and understand it, okay? And what we started doing is, is taking our knowledge of what that means and the guys that were looking at it, and we kind of determined there was a number of parameters that were really important, and we started taking algorithms against it, right? And then we're in the process of turning that into true machine learning, where it'll get better over time. And what we decided is that we could turn this into a health scorecard. So if I don't want to look at all this data, what I can do is look over on the right-hand side, and it's the famous red, yellow, green. And where are my UPSs relative to that? Which ones do I need to worry about, and which ones don't I? So yeah, there's going to be all these alarms coming in, right, that I might be interested in looking at, but on the other side, just show me, oh, I got to worry about those 5 today, right? And ideally, you click on it, it'll tell you what needs to happen, okay? And this is this is being rolled out as part of our EcoStruxure IT app as we speak. And you can kind of get something that looks like this. So I got 13 UPSs that are in big trouble, 4 that are, in trouble, 5, and then you see across, you get into the yellow and green. And so this will get better over time. As we put in machine learning, we're going to learn more about this. But we've started with kind of looking at this huge set of data, boiling it down, normalizing that data, understanding what are the important parameters, and now we can actually generate something that we can think be useful for managing these local data centers, right? And this is just one example of a UPS. I mean, you think about everything else that's going on, temperature, cybersecurity issues, alarming, and go to the IT level. We got a long way to go, right, to truly make these management tools. And so this challenge over managing the edge, again, we are in early days, right? But it demands really a rethinking of how our management tools are built, at least in our view. We view this as a big shift. So again, summary of what we went through. Again, so you think about the complexity of this edge, what's it going to take? First of all, the ecosystem needs to work together differently. We heard a lot about that. If you listen to Dean, I mean, I was hearing these words coming out of Dean Nelson and Joe Cava. Everyone was talking about, we got to work together to solve some of these problems. It's really significant, I believe, in this local edge. Also with the local edge, I see no way that you do this without having a truly cloud-based architecture on your management tools. You've got to get the data into a big data lake. By the way, once I do that, we will be making public APIs over the next year. We'll start rolling this out so that can be easily accessible by anybody. Okay, so in the past you have this on-premise software, you have software that's in data that's difficult to get to. We're going to pump it into the cloud, and then we're going to make APIs into that cloud. So basically, the whole ecosystem will be able to get access to our data and our algorithms. And then ultimately, a strong industry foundation for applying AI. That's really what we're working on today. Is how do you take those subject matter experts, that understanding that we've got, normalize the data, and pair it up with data scientists. That's the thing that the industry needs to work on, and we need to do it within ourselves so we can understand our stuff. But then how do we get that capability also matched up with the other key players in the ecosystem? So I think this is part of the reason. I came to the conclusion after putting this together, this is why the industry is confused, is because this is a very difficult problem. It is not simple. And in order for us to really realize the benefit out of it, it's going to take significant changes, not only just in the technology. We'll solve the technology, but how does the industry work together in different ways? That's the hard part, right? So we think we're well on our way, but again, still a long way to go. So I'm done. Did I land on time? Pretty close. So thank you very much.